Okay, now we're going to tackle transformations. First, I want to give you a general overview. When you're performing transformations, you first want to take care of any vertical or horizontal compressions and stretches, then take care of the reflections, and finally take care of the vertical and horizontal shifts. The order does matter, or you could end up in an incorrect location. This is a big theme in Algebra 2, pre-calculus, and even in calculus when things get moved. So make sure you have a clear understanding. Let's get started. Okay, so here you have a function. This represents a function. There's a number on the outside of parentheses, and inside there's some stuff. N just represents any integer. It could be the first power, second power, fifth power. It could be a fractional exponent. I just want to represent all the different pieces. All right, so stretches and compressions, remember, that's what you're going to take care of first. There's vertical and there's horizontal. Notice I have them color-coded. Everything that impacts the height of a function is color-coded in blue, and anything that impacts the left and right movement of a function, or what appears to be left and right, that's color-coded in red, so horizontal. So on the outside of parentheses, vertical, on the inside of parentheses, horizontal. For the reflections, the same is true. The blue ones, the blue numbers, so if A happens to be a negative number, you're going to reflect over the x-axis, because think about if you're flipping over the x-axis, that is movement up and down, right? And then if the B is negative, you're going to flip over the y-axis. And both of them can be negative. You could first have to flip over the x-axis, then flip over the y-axis, or either order, that's fine. This is especially true in square root functions, where you'll see some of that happen sometimes. But if the A is negative, flip over the x-axis, B is negative, flip over the y-axis. And finally, the shifts. This is movement up and down or left and right. D, the blue, is you go up or down. The C, you go left or right, but whatever the opposite of this is. So let's say this would have been -5. The opposite of -5 is +5. So you'd move to the right 5. All right. Stretches and compressions. These are a little bit confusing, so try to stay with me. So again, right here, the A, that essentially impacts, I would say, the Y values, but it's not that simple when it comes to this. But, oh, did I freeze that? That's not good. All right. If A is an integer, then it's a vertical stretch. And this is what I mean by that. So if you have a quadratic function, right? If A is, say, 3, then imagine that you pick up the parabola and you stretch it upward. Well, all of a sudden, you're going to have a much thinner parabola. That's a vertical stretch. If A is an integer, you're going to have a vertical stretch. If A is a fraction, then you have a vertical compression. What I mean by that, let's say A is 1/2. Well, it will be half as tall. That's one way to think about it. So imagine you have a parabola. Let's go back to the original blue one right here. Well, if A is a fraction, then imagine you're pushing down on it, you're compressing it, and it becomes flatter. Okay, so this is a vertical stretch, horizontal stretch, vertical stretch or vertical compression. Now this is the tricky part. When you switch to horizontal, you're going to reverse the process. So what I mean by that is, if b is an integer right here, then you have horizontal compression. And this is what I mean by that. So you've got a regular parabola. If b is an integer, remember, inside the parentheses, there's movement left and right, not up and down. So it compresses. If b is an integer, it's going to compress, and again, you're going to have a much taller or a much thinner parabola, but it's going to be thinner than even this one would for a stretch, because if this is squared, oops, I forgot to put the n out there. If that's squared, this will be much taller than if it's not squared. So if it's an integer, if b is an integer, it's going to compress horizontally the parabola. And if b is a fraction, then imagine you take this original parabola and you pull on it, you stretch it, and when that happens, you're going to get a much wider parabola. So anyway, this one you might want to have to look over a few times. It can be a bit confusing, but this is the easiest way that I have of explaining it. All right, reflections, and I've already kind of explained that. If A is negative, then you're going to reflect over the x-axis. And if B is negative, you're going to take that and you're going to reflect that over the y-axis. And then finally, shifts. This one a little bit careful again. D, whatever this is, you're just going to do exactly as it says. So if that says +3, you'll take the entire graph and move every point up 3. If that would say -3, you'd move everything down 3. For the horizontal, this is where you move left and right, but the reason I say you have to be careful with this, remember, the c values trapped inside the parentheses with an x. Well, we want to zero out the x. So it's whatever zeroes out the inside of the parentheses, that's what you're going to do left or right. So it will be the opposite sign of whatever's inside the parentheses. All right, this is it for transformations of graphs. And remember, these transformations apply to all of the graphs. Doesn't matter if it's a root, if it's a polynomial, if it's a rational function. It doesn't matter, in fact, if it's a trig function, right? This is how what we discussed is how transformations are done. All right, that's it for this video.